Here's the answer to question 1E. So we've got our normal distribution still, but we are told some more information, so we're going to be changing the original data. So we've been told that a doctor is investigating babies born in the UK, so we know that that's different from babies born in New Zealand. Okay, so she's been told that the weight of babies is normally distributed with a mean of 3.2 kg. We've also know that the percentage of low birth weight babies, so those are weighing less than 2.5 kilos, is 6%. And we've been asked to work out the standard deviation. Okay, so we need to, what we normally would have as our normal process to find a probability, if we did it the full way, not using the graphics calculator, is we would start off with a normal distribution with a mean and a standard deviation. We would then convert that distribution into the Z distribution. Okay, so we would have an X distribution that we convert to the Z distribution. Now, in the X distribution, whatever the area that I wanted to shade in, I would be able to find the value of exactly the same there, but the Z distribution is special because it has a mean of 0 and a standard deviation of 1. And it has this little Z value, which we're going to find down there. This is still a probability, just like in this one, that's a probability, but that is my X value there, whereas now I've got my Z value. Okay, now to do that conversion, we would use the formula Z equals X minus the mean over the standard deviation. Now that formula is on your formula sheet. And once we had this as a Z value, we would then go to the normal distribution tables. Okay, so that would be our next step, would be to go to the tables and find the probability. So what we need to do is, because we've been given a probability, 6%, we need to reverse this process. Okay, so let's start by drawing what we know. We know we've got a normal distribution and that it's got a mean of 3.2 kg. So I'm going to do that as 3,200 grams. Okay. Let's write it as 3.2. Then I know I've been told that babies that weigh less than 2.5 kilos, so on my number line, I'm going to put there's my 2.5 kilos, and I'm going to shade in the area less than that. And I'm told that area is 6%. Now 6% is a decimal. If I turn that into a decimal is 0.06. Okay. All right. Now what I need to do is I need to take this diagram that I've just drawn and compare that to the tables and the diagram on. So the diagram on the tables, and I'm just going to redraw our diagram here. Our diagram looks like that. If I compare that to this one here, you can see it's coloured in between 0 and some value Z. Alright, so it's coloured in that part. And so the probabilities, now the probabilities are these numbers in here. Alright, these numbers in there. These are our probabilities. And the values on the outside are our Z values. So all these values and those values are our Z values. All right. So we know that this area is 0.06. Now I also know if it's a normal distribution, it's going to be symmetric. So that I know from the mean, okay, that means 50% of the data is on one side and 50% of the data is on the other side. So to find this area here, I know that the little tail is 6%. So to find this area there, it's my whole 0.5%, which is all of that side, minus 0.06, and that means the value there is 0.44. Okay, so that's this area in here. That area there is 0.44. All right, so I know that that is also going to have a negative Z value. Let me just rub that out a little bit now because I don't want to get too much on this diagram. So I know, oh, that is going to have a negative Z value. Now, because it's symmetric, it's equivalent on this side to a Z value, where that area is 0.06 and this area is 0.44. Because I've got a mean of 0, these Z values are opposite. One's positives, one negatives, but the value is the same. So I need to look in this section here, I need to look for a value of 0.44. So I am going to do that and look for 0.44. So I'm going to start just by coming down these numbers, 0.1, 0.2, 0.3, 0.4. I get to 0.43 and the next one's 0.44. So I know it's going to be somewhere around here. So I'm going to start having a look along this line to see where it changes from 0.43 to 0.44. And I can see there we've got this value here of 0.4394 and this next one is 0.4406. So 0.44 is going to be somewhere between those. So I'm going to take the smaller value, 0.4394, and what I am going to do is I am going to look along that same row, okay, along a bit further, and think how much do I need to add to this number to make it up to exactly 0.4400. So I would need to add another 6 to make that add up. Yep. So that's what I'm looking for in the differences section here. And there's my value of 6. Okay. So I've got my value of 0.4394 plus that 6 together will make an answer of 0.44, which is what I'm looking for. Okay. Now what I need to do is I need to go back along that row. There's my Z value 1.5. I need to go up. This is the second decimal place. So far I've got Z equals 1.5. The second decimal place is a 5. And then I'm coming along to where that 6 is and going up there. And that is also a 5. So that's my first, second and third decimal place numbers. Now remember I said with Z, we need this to be a negative Z value. Okay, so there's your first step, is to find that Z value. Now, if you're able to do that, then that gets you a U. But now I need, if I go back to the original process, I have gone to the tables and found the Z value. Now I need to go from that, using to the formula, to find and solve. Okay, so that's what my next step is now. So I am going to substitute Z equals negative 1.555, and I'm going to substitute, do I need the standard deviation? No, but I know the mean is 3.2. I know I've got a mean of 3.2, and I know I have this value of 2.5, so I know my X value is 2.5. And I'm going to substitute those numbers into our formula. Z equals X minus the mean over standard deviation. And if you just look at the top of the table, that formula is given to you there at the top as well. So you don't need to memorise this formula. You just need to how to use it. Okay, so let me just go to a new page where I've got a bit more room. So, we've got Z equals X minus the mean over the standard deviation. And we know Z was negative 1.555, our mean is 3.2, and our X is 2.5. So, substitute those values in. So in place of the Z, I'm writing its number. In place of the X, I'm writing its number. In place of the mean, I'm writing its number. And I don't know what the standard deviation is, but that's what I am now going to solve. So, I have divided by the standard deviation. I want to get rid of that. The opposite of dividing is multiplying. So I'm going to take that to the other side. All right, so I'm going to move that standard deviation to the other side. And that's going to mean I have negative 1.555 times the standard deviation equals 2.5 minus 3.2. Now let's just do a bit of tidying. 1.555 times the standard deviation equals, now 2.5 minus 3.2 is negative 0.7. So I'm just simplifying, tidying it up. Now I want to get the standard deviation by itself, because that's what I'm trying to solve. So it means I want to get rid of this negative 1.555. So I want to take that to the other side. Now the opposite of multiplying is dividing. So now I'm going to do standard deviation equals negative 0.7 divided by negative 1.555. And I'm going to get my calculator out and just type that in. And that is going to give me an answer of 0.4502. And that is to 4 decimal places. And that there is my standard deviation in kilograms. So we looked at where we could get our U, which was to find the Z value. If you are able to substitute into the formula correctly, so if you are able to do this step here, then that would get you the merit level. And if you're able to get to this final answer here by rearranging, then that would get you the excellence T. Now this question also could have gone the other way and asked you to find the mean instead of the standard deviation. But the process is the same, it's just the rearrangement of the formula that would be different.